So here is 1.3b in college algebra as we get started here with the very first example. First example says that graph the function f of x equals negative 2/3 x plus 1. Alright, so one of the things I teach when I do this is you have to know what your slope is and your y-intercept in order to graph. Okay, that's going to make life so much easier. So the book starts out saying, okay, the best we can do is take any numbers we want and plug in for x. So let's plug 3 in. And then I put a 3 in here. And that gives me my x and my f of x, or my y. So if x is 3, what's my y value? Negative 6, negative 2, plus 1, negative 1. Okay? If I put in a 9, I get negative 2/3 times 9 plus 1. So when x is 9, my y is negative 5. Okay? And I can just put in a whole bunch of numbers and get a 3, negative 1. So I'm going to graph that. And let's do that in yellow. 3, negative 1, that gives me a point right there. And then 9, negative 5 gives me a point right there. And I can draw my line there. Okay? One of the ways I can check this is to find out if the slope of this is the slope in the original equation. So the way I do that is I take my 2 points that I found, and I use the formula like that. So let's do that. Let's put y2, let's put a negative 1 in there, minus, what's the other y? A negative 5, over, my x is 3, minus 9. Okay, so let's see what we get for a slope. I should get negative 2/3. This is just a check. So negative 1 plus 5 is 4 over 3 minus 9 is negative 6, which reduces to negative 2/3. So that does work. I did get the same slope as they told me in the original problem. So that's good. Alright, another way you can do this so that you don't have to do so incredibly much work, and we're going to get to this later, is if you're given the slope and if you're given a y-intercept, you can find you can graph this real easy. Y-intercept just means where does it cross the y-axis, right there. So you put that point on there. And then this tells you your slope, which is y over x. So negative 2 over 3. So your y is negative 2 and your x is 3. So you start here where it crossed the y-axis and you do what it says. Down 2, 1, 2, over 3, 1, 2, 3. And there's a point. Down 2, over 3. Doesn't matter where you start on the line. When you go down 2 and over 3, you're going to end up with a point on the line. So down 2 over 3 gives us this point here, and we have that line. So we just didn't have to do near as much work. But I don't think they want you to learn that yet, but you should already know that. Alright, so let's keep going here. And one of the things that I want to remind you of is when you have a slope that goes from left to right and it goes uphill, it is a positive slope. When it goes from left to right downhill, it is a negative slope, which is what we have right here. This red line is the slope, or is the graph of this line with a slope that's negative because it's going downhill from left to right. Okay, so let's jump to example number 2. Get rid of some of this stuff here. In example 2 says graph each linear equation and determine its slope. So we've got our first linear equation as x equals negative 2. Alright, so remember, if we're graphing this and x is negative 2, that means x is right there. And y doesn't matter what it is, it's just going to give me a vertical line. So whenever you have x equals a number, you get a vertical line which means the slope is not defined. Okay, it asks you to determine the slope. When you're given a y equals 5 halves, so when you're given the y value, you go up 5 halves, which is 2.5, and you draw a horizontal line. So whenever y equals a number, you get a horizontal line. So x equals a number, you get no slope, and it's a vertical line. Y equals a number, it's a horizontal line, and the slope is 0. Okay, that's pretty much all you need to know there as far as that is concerned. If you can remember that, that will save you a lot of grief later on. All right, so let's go with applications of slope. Slope has many real-world applications. Okay, so we're going to look at specifically example 3 on page 96. And we've got, several of these to go through. It's got a ramp for the disabled. Construction laws requiring access ramps for the disabled state that every vertical rise of 1 foot requires a horizontal run of 12 feet. Okay. So rise is the up and down, run is the left to right, the horizontal. All right, so for every 12 feet, the most you can rise is 1 foot. And so what are they asking? What is the grade or slope of such a ramp? Okay, so we're using the slope formula, which is m equals y over x. Well, what is my y? 1. What is my x? 12. Take your handy-dandy calculator out, and you get 0.083 or 8.3% grade. Grades are usually in percentages. So this is the slope. This is the slope put in a percentage. All right, so that slope is considered an average rate of change. Means that every 12 feet, on average, it rises 1 foot. All right, so let's go ahead and look at example 4. First of all, if you look at the bottom of page number 96, it says slope can also be considered as an average rate of change. To find the average rate of change between any two data points on a graph, we determine the slope of the line that passes through the 2 points. Because sometimes you're going to get a graph that may go like this. Okay? So the average rate of change from here to here, or the rate of change from here to here, may be different than the rate of change from here to here. Okay? So basically what we're doing is kind of drawing a line that goes kind of straight through all of these and finding the slope of that to give us the rate of change. So that's the average is what we're kind of looking for there. All right, so travel agencies. The percent of travel bookings online has increased from 6% in 1999 to 55% in 2007. So in 1999, we had 6% of people booked online. In 2007, that number had risen to 55%. Okay, so basically what we're doing is this is the x value, this is the y value. This one here, x value, y value, x value, y value. So if we were to graph this stuff, we could say that in 1999, we had 6%. And in 2007, we had 55%. And obviously, it had its ups and downs as it went from here to here, but it steadily grew. Okay? So it may have done this as it was going up there. So what we're looking for is the average rate of change in the percent. So what we're going to do, rate of change is slope equals the change in y over the change in x. All right, so what is the change in y? What was the change in y? It was 55 minus 6, right? That would be the change because we went from here to here. So how much difference was that? So that's 49. And what is the change in x? 1999 to 2007. So 2007 minus 1999, which is going to give me 8. So that's going to be my slope, 6 1/8. Okay, so what that does is that tells us that each year from 1999 to 2007, online travel bookings increased by 6 1/8%, okay, per year. That was the average rate of change over that 8-year time period. So what we're finding is the change, the slope going from 1999 to 2000, 2000 to 2001, etc., was 6 1/8 per year. Okay, so that's what we did there. All right, let's go ahead and look at, see if we can get through example number 5. Drinking less soda. In 2002, 57% of beverages sold in high schools were carbonated. In 2005, the percentage decreased to 44.9%. Okay? They give you a graph below, and they want you to find the average rate of change from 2000 to 2005 in the percent of beverage sales that are carbonated soft drinks. So they're looking at year to year what's happening. So we've got our coordinates. 2002, 57, 2005, 44.9. So we're going to use our slope is our change in y over our change in x. Whenever they're asking for rate of change, it's going to be delta y over delta x. So it's going to be y2 minus y1 over x2 minus x1, which just means you're going to take your two y values and subtract them. And your 2x values and subtract them. Okay, so I had 57, I used this one, so I have to use 2002 first. So 57 minus 44.9 is 12.1. 2002 minus 2005 is a negative 3. So that gives me a negative, approximately a negative 4% change each year. So the amount of pop people drink goes down 4% every year. That's what the negative means, is it just went down 4%. All right, let's look at example 6 real quick. An anthropologist can use linear functions to estimate the height of a male or female given the length of the humerus or the bone from the elbow to the shoulder. The height in centimeters of an adult male with a humerus of length x in centimeters is given by the function that they gave us there, which we don't have to understand what that means. We just have to be able to use the formula. Okay. So there's the formula. The height in centimeters of an adult female with a humerus length x is given by this other function. And because they're doing females. The top one is males, the bottom one is females, because apparently there's going to be a difference here. So we've got this formula. Alright, so we've got a 26 centimeter humerus was uncovered in a ruins. Assuming it was a female, how tall was she? So we're going to use this formula. We're going to put 26 in for x there, and we're going to get an answer. And that's it. Okay? So, that's it for the application. That's pretty much it for section 1.3. So we did that in 2 videos. Looking at the homework, 1 through 26. Doesn't really look like it's going to be any problem. You're just finding the slope and doing some graphing. 27 to 34, you're graphing the linear equations. So you're using your table like that in order to find out what that's going to look like. 35 to 40, all you're doing is finding the slope. So if you look at number 35, what is the slope? If it's in y equals mx plus b, the m is 1.3. Done. Okay? And then you've got some story problems there that hopefully won't give you too much trouble. I didn't give you a ton of them, and I just kind of picked ones that I thought were going to be okay to do. And that's it for lesson 1.3, and this is 1.3, B as in boy.